Hello and welcome. My name is Dan Meyer. I'm Editor-in-Chief of RCR Wireless News. Thanks for joining us today. Today I'm joined by Michael Thelander, who's the founder and CEO of Signals Research Group. Mike, thanks for joining us today. We appreciate it.
Sure.
Great. Well, so today's conversation is going to be a bit on some research you guys have recently done looking at 4x2 MIMO. You did some testing down in the Texas, I think around the Dallas area, on some 4x2 networks out there. And the research you put out was pretty interesting. So I was hoping to get from you perhaps a little more insight into what you saw down there, some of the results, and I guess some of the impact that this might have for networks going forward. So maybe start off with just a general overview of kind of what you did down there in Texas with this 4x2 testing.
Sure. So this is testing that we actually did back in early February. We just got around to putting out the report in the last couple of weeks. But this was done in collaboration with a test equipment company called AccuVer. And they provided us with their test equipment that allowed us to capture the information. You know, T-Mobile supported us to the extent that they gave us access to the network, or they told us where the cell sites were. They gave us access to a high bandwidth server for doing UDP testing, basically transmitting the data in the downlink and uplink. You know, we actually went out and purchased our own device, used our own SIM card. So to that extent, it was definitely autonomous from any other involvement from the operators. But this was testing we did over a 2-day period, you know, largely at night, but also during the day. And so kind of on the first night, we went out into a large cluster. It's about 120 square kilometers. It was a mix of both 4x2 closed loop cell sites as well as 2x2 open loop cell sites. And we conducted a drive test looking at the downlink and the uplink. On the second night, we went back out again and repeated the testing. In this case, the operator turned off MIMO in their networks, and so that gave us the chance to not only compare closed loop versus open loop and 4x2 versus 2x2, but also looking at the overall benefits of MIMO versus transmit diversity. And this is actually the second time that we've done this. We did a collaboration last year with 2 operators looking at MIMO as well, both with T-Mobile in Santa Clara, as well as another operator and network in Knoxville, Tennessee. So this is really more of a continuation, if you will, of that analysis.
Got it. Okay, and then I guess, so the testing you did, obviously very in-depth testing, got some good work there with T-Mobile on it too. What, I guess, break down some of the results you saw from this testing. Obviously, looking at the numbers, some pretty impressive numbers came out of it. What was your general view of kind of what came out of the testing? Yeah,
so first of all, I mean, this is something we actually put out in the report preview. We just kind of shared the overall distribution of throughput, and that gets a lot of people excited in terms of the capabilities of LTE. And as I think, as most people are aware, historically in the U.S., most of the LTE networks have been limited to 10 megahertz of downlink and uplink bandwidth, if you will. Mm-hmm. T-Mobile is now in the process of rolling out both 15 megahertz and 20 megahertz channels. Verizon as well is now putting out 20 megahertz channels. So when you do that, you basically get a theoretical doubling of the data rate over the initial LTE networks in North America. Second of all, you've got the availability of Category 4 devices. Mm-hmm. Historically, we started off with a Category 3 device. The real difference in layman's terms is that a Category 3 device is limited to 100 megabits per second or thereabouts. A Category 4 device will take you up to 150 megabits per second. Mm-hmm. Now, kind of looking at the numbers, if you look at an overall distribution of throughput, now this includes both the 4x2 closed loop cell sites as well as the 2x2 open loop cell sites, we saw an average downlink throughput of 36 megabits per second. 95% of the time, the data rate was greater than 10 megabits per second, which I would argue, for most applications, 10 megabits per second is more than ample. And then for 60% of the time, the throughput was actually higher than 30 megabits per second. And again, this is a composite of both 4x2 and 2x2 cell sites. And then in the uplink, the average throughput was 28 megabits per second. About 87% of the time it was greater than 10 megabits per second, and then roughly 50% of the time it was greater than 30 megabits per second. So again, very impressive. Granted, a lot of that testing was done during the nighttime, but even during the daytime when we went out, still very, very strong data rates.
Gotcha. Now, was there any sort of impact on, I guess, the coverage of each site as well? I mean, obviously, that's always an issue with, when you start loading up these networks. Sometimes coverage can be kind of variable. Do you see any sort of, I guess, impact of the 4x2 when it came to overall coverage?
Coverage as compared to a 2x2 site?
Yeah. Yes.
Yeah, definitely. I mean, that's really the benefit, or one of the biggest benefits of a 4x2 configuration. And just to back up for a second, there is some confusion, I think, in the industry when they talk about 4x2, 4x4, 2x2, etc. So I want to make sure the listeners understand what we're talking about here. So when I say 4x2 cell site, what I'm really talking about is 4 transmit and 4 receive antennas at the cell site. The 2, if you will, is on the mobile device. So you have 4 transmitters and 4 receivers at the cell site. You have 2 receivers in the mobile device. You compare that to a 2x2 configuration, and it's basically 2 transmit, 2 receive at the cell site, and 2 in the mobile device. The next step, if you will, is 4x4 MIMO, and in that case, you actually have 4 orthogonal data streams in the downlink being combined with 4 receivers in the mobile device. So now getting back to your original question there, so definitely the benefit or the biggest benefit of the 4x2 configuration is in the uplink. And the reason being is that you have 4 uplink antennas, combining the data. You get some diversity there. So you really start to see some very strong gains, especially at the cell edge. And so one of the things we did is we would separate the data between the 2x2 cell sites and the 4x2 cell sites, and then look at uplink and downlink performance as a function of downlink path loss, as a function of SINAR, as a function of signal strength, and kind of do a distribution to say, okay, for a given signal strength, how does the throughput vary between the 2 cell site configurations? And the answer is it's dramatic. You definitely see that, if you're in a 2x2 cell site compared to a 4x2 cell site, once you start getting closer to the cell edge, and the cell edge is being defined by kind of a higher path loss, lower received signal, the number of network resources that get assigned to you, or the resource blocks starts to fall off because your transmit power limited. Your mobile device can't transmit across the entire 10 megahertz of spectrum, so it has to back off. And when it does that, you can't send as much data. The other thing you see is that just the modulation encoding scheme, or the amount of bits that you can send in one transmission, it starts to drop off when you have a 2x2 cell site versus a 4x2 cell site. So what that means is, from a user's perspective, you definitely get much higher data rates, and it's roughly 2 to 4 times higher data rates at the cell edge. So that's definitely a user benefit. The other benefit is for the operator. So you look at more efficient scheduling. If you can take a given amount of data and send it more efficiently, that frees up capacity for other users in the network. And so it's really a win for both the user as well as for the operator.
Got it. So you're getting that increased diversity back at the site, which is allowing the site basically to have bigger ears perhaps for listening to the device that's perhaps at the cell edge, sending the transmission data back to the site?
Correct, yeah. And there's also benefits in the downlink. I mean, we definitely saw that as well. It's not necessarily as dramatic, but clearly, 4x2 MIMO is all about the uplink. And I think what a lot of people don't realize is that in any network, 3G, LTE, etc., you're always uplink limited. And so if you can't connect to the network, you have to remember your mobile device is transmitting at a much lower power level than the cell site. And so anything you can't transmit at a higher power level in the mobile device, because then you have SARS issues and cancer and everything else that can come about. Not to mention the impact on the battery life. So you're limited there.
Yeah.
And so the only way you can make that up is that, as you said, having bigger ears at the cell site.
Interesting, interesting. So yeah, you kind of brought up the more efficient use of the device itself. I know you mentioned in the report a bit about seeing perhaps some better battery efficiency on the device itself. Is that basically because, again, like you were saying, that you're able to be more efficient on the network? The device isn't having to kind of, I guess, scream as loud to reach the antenna site. That results in more efficient use of battery life for the device itself.
Yeah, exactly. So for any given signal strength, so in our case, we were doing UDP, just to back up. So we were trying to send as much data as possible all the time. And what we saw is that for a given signal strength in the downlink, the amount of transmit power in the uplink was, roughly 6 dB, or almost 2 times lower than it was with the 2x2 cell sites. So what that means is, if you're not transmitting at a higher power level, that's battery efficiency. Now, we didn't actually quantify what that savings would be. It's a little bit difficult because it depends on what you're doing with the mobile device. Is your screen on? All those types of things. Yeah. But clearly, if you're transmitting at, a quarter of the transmit power, there's a huge impact on the battery life. And then on top of that, you're transmitting at a faster data rate. You're doing it more efficiently. So not only, it's basically a triple whammy in that you're transmitting at a lower power level, and you're also transmitting more data, which means you're staying connected to the network for a shorter period of time. Yep. And so that all kind of multiplies itself out and should have a really big impact on the battery life, which again benefits the consumer.
Yeah, yeah. And for anybody who's ever been, with the device on a cell edge or in an area where there's very, low coverage, the device is always pinging the network, trying to get a signal, and you can just watch your battery life just drain right out of the device. So obviously, like you said, if you're on a cell edge with a stronger signal coming out from the antenna, or better listening from the antenna, that would definitely seem to help that situation out in the real world.
Correct. And the other interesting thing is that, a lot of the benefits we saw with the 4x2 was more so at the cell edge. Now with the battery life, that was an impact that we saw, virtually across the entire cell. Because even as you're closer in, where you have a stronger signal, you're still backing off your transmit power. And I think the other thing to add is, at a certain point, when you're at the edge of cell, and both networks are transmitting at max power level. So it's not like you can back off. At a certain point, you're going to be transmitting at the highest power level in both configurations. But across a very large percentage of the cell, there's multiple dB lower transmit power in the 4x2 cell site.
Gotcha. Okay. And obviously too, with kind of consumers are using more applications now that aren't just receiving lots of data. Now they're starting to transmit a lot more data too, whether it's video or whatever it is. So it seems like getting that increased data throughput on the uplink is a good benefit going forward. Again, as consumers start to use more of these devices, those applications that do more of that type of transmission.
Yeah, and especially things like VoLTE.
Yeah.
I mean, VoLTE, that is a very low bit rate compared to what you'd be doing, or what I was doing out there with UDP. Where you're trying to send 30 megabits per second versus 30 kilobits per second. But even 30 kilobits per second, if you can transmit at a lower power level, or if you can transmit further, that's going to be a big impact there as well. And then things like video telephony, be it operator offered or third party over the top application like Skype.
Yeah, that makes sense. Okay, that's very interesting. Now, again, you did a lot of this testing, like you said, kind of at night, but you also did some testing in the daytime as well. I mean, do you expect the same kind of benefits once the network is perhaps more fully loaded with perhaps more Category 4 devices, or I guess, do you expect any sort of change in perhaps your results once perhaps 4x2 is more mature in the market?
Yeah, so I mean, definitely, we'll take Category 4 devices, for example. The ability, they really only benefit the consumer, by and large, when you get above 100 megabits per second. There are some differences at lower data rates, but by and large, you really need good conditions and lots of resources in the network being scheduled to you to see the benefit. So yeah, if you have a loaded network, a Category 4 device is not going to benefit you nearly as much, or it's going to benefit a much smaller subset of devices, those that are closer to the cell site, et cetera. I think when it comes to things like power consumption, those benefits will transcend a loaded network versus an unloaded network. You'll still see those benefits. I think it is fair to say that in a loaded network, the incremental differences will not be as great to the consumer, but from an operator's perspective, the overall network efficiency is still just as good. In fact, it's more important. If I'm the only user in the cell site, it doesn't matter how efficient you are at scheduling me. It doesn't matter. Now, if you have 50, 100, 150 subscribers in that same cell site, then efficiency really matters. And so if you're not efficient in scheduling your resources, you start to run out of capacity. That hurts the operator. And then from the consumer's perspective, if the network's not very efficient at scheduling resources, my data rates are lower than they would have been otherwise. Maybe not nearly as great as they would be in an empty network, but it's all relative in a way. So you try to get as much out of the network as possible.
Yeah. Well, and obviously network efficiency is always a big win for carriers, always looking for as much as they can, whether it's even a megahertz here or there that they can save out there is pretty important for them. So any sort of efficiency gain there is always a big move for operators. So well, now I guess looking at this too, it sounds like the 4x2 MIMO, at least from T-Mobile's point of view, I think they've been pretty aggressive in rolling it out commercially, or at least to some of their networks. I guess is the 4x2 MIMO, from your point of view, how widespread are these deployments? And are they deployments that carriers you think are going forward with now, or is it something that maybe is something that's going to be maybe a little more future looking, or what's the rollout time frame from your point of view for 4x2 type of MIMO deployments?
Yeah, so I think for starting with T-Mobile, I mean they've been very aggressive. In fact, their parent company is also very aggressive in trying to push 4x4 MIMO.
Yeah.
So they're very aggressive. In general, I think in the last 6 months or so, T-Mobile has definitely rolled out 4x2 in a lot more markets than they had back in February. A lot of it also depends on the infrastructure, and the vendor you're working with, and kind of the time frame when you deployed their infrastructure. So if you go back to some of the very legacy E-No-Bs and the radio heads that were deployed, it may take a hardware upgrade to go from 2x2 to 4x2. That may not be the case for more recent solutions from certain vendors. And so I think it really depends on where the operator is at in the roadmap. But if you look at all the benefits that there are to a 4x2 configuration, it's really hard to imagine operators not going down that path at a certain point. I think it really comes on where they're at in the roadmap, where their vendors are, but it's, you look out a few years, it's hard to see, big operators sticking with the 2x2 configuration. It just doesn't make sense.
Mm-hmm. Well, I mean, I guess then looking at that, then would they be waiting for perhaps even waiting for like a 4x4 type of implementation, or is 4x2 kind of the near-term one to go with, and 4x4 might be something a little bit farther down the road?
Yeah, well, I mean, 4x2, I mean, the best thing about 4x2 is that all of your devices support it. Okay. From day one, every single LTE device in your network, it has 2 receive antennas, and it doesn't care if there's 4 transmit antennas and 4 receive antennas at the cell site or not. So you get a definite bang for your buck. Now, when you're talking about 4x4 MIMO, now you have device chipset implications. And until we get chipsets out there in devices that support 4x4 MIMO, operators won't have any reason to do it. And that's one of the challenges T-Mobile, from a global perspective, has faced. And then even once you get chipsets out there that support it, it's still going to be a subset of devices. And so the real benefits, like if you will, of 4x4 MIMO are only realized when all of your devices, or a large percentage of them, support the capability. But I think over time, I mean, we're talking about massive MIMO now with kind of the next generation, or even LTE advanced, where we're talking, 50, 60, 128, transmit receive antennas. So I think 4x4 is, very modest, compared to those grandiose visions.
Yeah, interesting. Well, again, it was a very interesting report. I definitely recommend that those who are watching this, if you're interested more in it, go to the Signals Research website, check it out. And I know they've got a lot of other interesting reports on there. Again, a lot of them are a lot more in depth, perhaps, than maybe people are comfortable with. But I gotta say, they're very informative reports, lots of in depth. I don't want to say nerdy type of information there, but there's a lot of numbers, a lot of interesting numbers in there. I know you guys do a really good job at getting that research. So I would say it's a very informative information you guys bring out to the table. So that's always good to see. Well, I guess on this topic here, I mean, was there anything else that perhaps I didn't cover that you wanted to touch on at all when it came to this report?
No, I think you covered all the objectives of the study that we identified.
Okay, so again, I definitely recommend those watching to go to the Signals Research website, check it out. If you got any questions, I think you can contact Michael right from the site there. You can bombard him with questions. He would love to answer all of those, I'm sure. But again, hey, Mike, we definitely appreciate the time today. Thanks for all the information. We appreciate it.
Sure, thank you.
All right, thanks.